The universe, in the first billion years, went from a smooth, featureless gas expanding to a place where galaxies formed, inside the galaxies stars formed, and the radiation from the stars leaked out to ionize the hydrogen atoms in the gas between the galaxies. And that process is called the epoch of reionization. Our group has just performed one of the world's largest and most sophisticated computer simulations of this process, how gas was clumped into the cosmic web, made galaxies and the star light then swept across the intergalactic medium. And being able to visualize that and predict things that astronomers can observe is a beautiful thing.
Hi, my name is Jeffrey Lee, and my image is of two human microvascular endothelial cells and tunneling nanotubes in between them, allowing them to communicate and transport cytoplasmic components between them, which is a really cool concept in that even at the most basic component of life, of human beings, our cells, communication is still highly important. And it's really the tree of life, which is what the image looks like and represents to me.
The 17 by 17 challenge has been online for quite some time. A challenge of coloring a grid of 17 by 17 cells in such a way that for every rectangle holds that with rectangles of at least length 2 and width 2, that all four corners cannot have the same color. I think it's intriguing that if you try to avoid one pattern, that you are forced into another one. And if you look at, for most of these puzzles also, that if you look at the normal solution, then you don't see that there is any structure in there. There is a solution, but not only is there a solution, but there's kind of a beautiful solution, or there's some real clear structure. Chaos does not exist.
So my name is Peebles, and I work for Brent Iverson in Welch Hall. And the image I submitted to you guys was of a donor acceptor dyad in a solid state, so it's a single crystal. And as you heated the crystal, it would change from red to yellow over the course of about 30 seconds. It's fairly serendipitous. You know, one night, it was like Friday, and it was 11 p.m., and I was just kind of here, and I was frustrated with the project because it wasn't really going where I wanted it to. So I said, okay, let's just heat it up. Sometimes if you heat something, it'll change color, or it'll melt, or something cool might happen. And so like 11:15, you know, I was aggravated, I threw on a hot plate, walked away, and when I came back, you know, this color change had happened, and I was like, well, maybe we're onto something now.
My goal with this photo was to give the viewer a sense of the engineering and scientific complexity involved in the creation of the star detector. Because of the high contrast and detail in this photo, we experience the detector as an amalgamation of many different parts rather than as a single static entity, which emphasizes its construction rather than its existence as a completed detector. This photo also represents the cooperative and collaborative nature that has allowed humanity to achieve great feats throughout the course of our history. And it is a statement that cultural differences can be reconciled and language barriers overcome when we come together with a clear vision backed by hard work and determination.
One of the reasons we chose to image copepods is because they are one of the most abundant animal groups on the planet and form crucial links in aquatic food webs. For me, the most interesting part about creating this image is the ability to see the result with all of its amazing colors in real time without the need to stain or otherwise manipulate the organism. So we hope that by acquiring these beautiful images of copepods, it will actually help us to unlock some of the secrets to their impressive escape capabilities and to teach us more about the evolution, ecology, and physics behind important predator-prey interactions.